Hello everyone, in this lecture we will talk about system of linear equation and different types of ways of solving these systems. So system of linear equations is a set of two, three or multiple linear equations altogether. So let's just say that I have a system of linear equation comprised of two equations, so y equal to x plus 2 and the other one is y equal to 3x minus 2. So we have this kind of like symbol here, just to signify that this is a system of linear equations, system of two linear equations. In your textbook it doesn't use this symbol, that's okay, and in the exam you don't need to use this as well. So how are we going to solve the system? So we need to talk about a solution. Okay, so let's talk about the solution. Now the solution of a system linear equation is any order pair that makes all of the equation in the system true. Okay, so solution is any order pair. Any order pair. So in this case, we have two variables x and y, so any order pairs x, y, that makes the system all, okay, that make all equations in the system true. Make all the equations in the system true. So in class I already talked about the statement and give an example of what does it mean when you say the system true. So to solve this we use the technique called graphing. Okay, graphing is one of the basics ones. So how do we graph this? Okay, so this one, fortunately for us, this is in the slope intercept form. So you only need again y equal to mx plus b. So in this case you already know the b, okay, which is the y-intercept. So the y-intercept has the coordinate x equal to 0 and y equal to b. Okay, so you have the first point here, and then this is the first step. The second step would be you use the slope here, and the slope again by definition, slope equal to rise over run. Okay, rise over run, and what happens is that from this point here you will rise, either go up or go down depending on the plus or minus on the top by how many units, and go to the right by how many unit, by that amount of unit. Okay, so I'm going to use the software here to graph this for us. So let's say my first equation is y equal to x plus 2. Okay, and it makes sense here because what happened is that we expect that our so this is y equal to x plus, this is y equal to x plus 2 here, and we expect this. Okay, y-intercept here, and then you go up 1 unit, and then you go right 1 unit, you see. And then the second equation is y equal to 3x minus 2. Okay, so minus 2, again y-intercept is minus 2, 0 minus 2 here, you see that, and our slope is 3, so we'll go up 3 unit. Here in this case we have go up 3 unit, 1, 2, 3, and go to the right 1 unit, which is over here. Now let's zoom in and see what's going on here. Oh, look, these two lines intersect each other at one point, you see, 1 point. And let's find the coordinate of this. the coordinate is exactly at this point here is x equal to 2, y equal to 4. Okay, so at this point here, we conclude that this is a solution for the system. Okay, so coming back, we have coming back here, we have from our graph, we have x equal to 2, y equal to 4 is our solution, is the solution of our system. Okay, of our system. Now you need to check this. Okay, so check is pretty easy. You need to check both equations. So let's say I would name this is equation 1 and this is equation 2. So you just have to plug in x equal to 2, y equal to 4 into 1. So let's check with equation 1. I have y equal to x plus 2. So in this case, y equal to 4 here, equal, this is a question mark, right? X equal to 2 plus 2, and we have 4 equal to 4. So this is true, right? This is true. Now let's check for equation 2. We have y equal to 3x minus 2. So y again is 4 equal to 3 times x, which is 2, minus 2. Again, this is a question mark because I want to check if this is equal or not. And again, 4 equal to 6 minus 2, which is 4 equal to 4. Alright, this is true. True. So I can conclude definitely that this x equal to 2, y equal to 4 is my solution of the system. Okay. So another one is the technical nomenclature, the naming of the system. So let's just say that a system equation that has at least one solution. So let's say that the system of equation that has at least one equation, one solution. One solution. So we would call this a consistent, okay, consistent system. All right. And a consistent system can be either independent or dependent. Okay, so a consistent system can be either independent or dependent. All right. So for example, in the independent system, we have exactly one solution. So exactly one solution. Now, dependent system, we have infinitely many solutions. We have infinitely many solutions. Okay. And then in a system that has no solution, okay, a system that has no solution, we call it inconsistent. We call it inconsistent. So if you take a look at this, you will see that there are three scenarios here about that demonstrate the relationship between the two linear equation or two linear graph. One is inconsistent, the other one is independent, the third one is dependent. Okay, so again, we have two big categories. One is no solution, then the system is called inconsistent. Now, the second scenario is if a system has at least one solution, then we would have, so it would be called consistent. But within the consistent system, we also have two other scenarios. Okay, so either it had exactly one solution or infinitely many solutions. Okay, so three scenarios. So let's see, how are they corresponding to each other? Now, the first one is inconsistent. Inconsistent means no solution. Let's imagine that you have two lines. Okay, you have two lines, and how would so this is M1, and let's see if the two lines have no common point. Okay, that means that the two lines do not intersect. So also known as, or also be interpreted as if they are parallel. Okay, in this case, the two lines are parallel to each other. Okay, the two lines are parallel to each other. So to do this, all right, let me see. Oh, okay. So to make it less confusing, let us label this as L1 and this is L2. So inconsistent means L1 is parallel to L2. And independent, exactly one solution. So exactly one solution means, let's say they have to intersect with each other at exactly this one point here, x, y here. So again, in this one, L1 and L2 intersect with each other. All right. And a lot of people confused about this. They say it has to be perpendicular. Well, perpendicular is also another form of intersection. Okay, an independent infinite manual solution is when two lines are literally identical. So L1 is identical with L2. Okay, so given this scenario already, with our understanding, we can actually uh, come up with a summary, uh, a algebraic summary of this. So we have these are called geographic, as a graphical representation. Okay, so these are geometry. Now, how can we interpret this to algebra? So we know that if the two lines are parallel, again, if assume that I have two lines here, and we only talk about two lines at the moment. We will later on discuss systems of linear equation, of multiple linear equations, more than 3, 4, 5. So, but we only use in scenario of only two. So let's say I have y equal to the first linear equation is y equal to m1x plus b1. This is the first one, and this so let's say this is L1, and y equal to m2x plus b2. So this is L2. Now what happens is that we're going to we're going to okay. Alright, so we're going to integrate this. Now, if the two lines are parallel with each other, then what happens? Then we learn that slope is the same. Slopes are the same, right? M1 equal to M2. And what else? Let's imagine that, for example, we have imagine a OXY here. So you see slope are the same, but then what's the difference here? They have different y-intercepts. So B1 has to be different from B2. The same thing for this one. We have two lines intersect. So the only condition we have is M1 has to be different from M2, and that's it. Now, with the two identical lines, we would have two requirements. The first requirement is that M1 has to be equal to M2 in these directions, and then B1 has to be equal to B2.